Hello, today we are going to showcase our latest Prodigy milestone by demonstrating the Instruction Profiling Unit or IPU running on our FPGA emulation system which runs the actual Prodigy design. As processors become more powerful and software applications increase in size and complexity, it becomes increasingly important to be able to create a detailed profile of the running software and identify the hotspots and reasons why some portion of code underperforms, so that they can be addressed and rectified. Addressing these troublesome areas can involve revising the code, using collected feedback for compile time optimizations, or both. In addition to simple periodic profiling and performance counter-based analysis, Prodigy has IPU subsystem that provides advanced profiling features that enable Prodigy users to collect fine-grained performance information that is localized to specific places in the code. The IPU can annotate collected samples with advanced attributes, including hit rates for all levels of cache, branch prediction outcomes, and many others. There are also controls which allow to filter subset of all possible samples without incurring extra collection overhead for undesired events. The typical flow for using the IPU is to first select the sample period based on amount of overhead acceptable in each situation, and when each sample period expires, take the instruction, record the properties, interrupt execution, allow profiler to collect the data from special registers, and resume. We have added IPU support to one of the most frequently used performance collection and analysis Linux tool, perf. Let's observe how a typical session would look like. We pre-booted our FPGA running Prodigy design to the point where we can interact with Linux command prompt. We'll speed up the recording while it's crunching. SysFS listing gives us some clues as which IP units and attributes are available for recording. We are using one of the modules of StressNG package to generate memory-related workload on the CPU core. Now that the recording is finished, we can bring the report up. You can see the histogram is annotated with hit-miss information for cache and TLB accesses, and data address being used in those accesses. This information came from advanced properties of IPU sampling events. Let's produce a raw dump of data that perf collected. Now let's scroll to some of the recorded samples to see what kind of data the IPU unit has collected. As you can see, there are even more properties available for further analysis. Some are related to executed branches and their prediction outcome. Extracting this information, converting it to G-code format and feeding it back during recompilation of performance-sensitive applications could lead to significant performance gains. That concludes our demo. Thank you, and be sure to stay tuned for future Prodigy updates and milestones.